We've consistently held the belief that we were the initial ones to split atoms and to modify the climate, to construct machines capable of transforming an entire planet. Yet what if that conviction is incorrect? Deep within ancient rock, ice, and ocean sediment, evidence lies that doesn't align with our understanding. Metallic spheres, shaped by extreme heat and abrupt carbon spikes, preserved within prehistoric ice. Residual radiation, sealed within stone from an era long preceding human existence. Scientists refer to this as the Silurian Hypothesis, a concept put forth by NASA's Gavin Schmidt and astrophysicist Adam Frank. It raises a profound question. If prior civilizations existed before us and ultimately failed, what significance does that hold for our current situation? Our exploration into Earth's concealed past commences not with the remnants of ancient cities or the skeletal remains of giants, but with something so minuscule it's easily missed. Minute metallic spheres, some scarcely larger than individual grains of sand. While others are small enough to balance on a fingertip, they have been encased within ancient rock for periods of time beyond comprehension. Yet their very existence prompts a crucial question that challenges the core of everything we believe we understand. Are we truly the first civilization to inhabit this planet? To comprehend why these small spheres are so disquieting, we must first examine what we already understand about them. In the modern era, when the initial nuclear bombs were detonated. In the mid-20th century, scientists meticulously investigated the aftermath. They uncovered the expected findings: craters, demolished structures, and scorched landscapes. However, they also discovered something far more unusual: the immense heat. The explosions had vaporized both soil and stone. As these materials cooled and fell back to Earth, they solidified into tiny, perfectly glassy beads. These are known as microspherules. They serve as one of the clearest geological indicators of nuclear activity. Fast forward millions of years. If another intelligent species were to excavate our planet long after our demise, they would not uncover our cities or our satellites. However, they would discover these spheres scattered throughout the Earth. Even if every trace of our civilization vanished, these small beads would endure to recount the narrative. Someone here mastered the splitting of the atom. This is what makes the discoveries within ancient rock formations so unsettling. Almost identical spheres have been found in geological layers significantly older than humanity itself. In South Africa, miners excavating deposits of pyrophyllite, a soft rock utilized in industry, stumbled upon hundreds of them. Some appeared smooth and nearly flawless. Others featured delicate grooves etched around their centers, much like manufactured ball bearings. Their makeup was metallic, containing high concentrations of hematite and other minerals not typically expected in such a context. Most astonishingly, the rock encasing them was over 3 billion years old. This period saw Earth as a hostile microbial world. Based on all current knowledge, no complex life existed, certainly nothing capable of precision engineering. These objects became known as the Klerksdorp spheres, and they have been a quiet source of contention ever since. Officially, geologists contend they are natural concretions, unusual but not impossible formations created when minerals aggregate under the appropriate conditions, but others remain unconvinced. Some of these spheres are so perfectly balanced that they can roll in a straight line across a surface, a feat that even modern machining struggles to accomplish. Photographs depicting spheres with flawless symmetry and precisely carved grooves only intensify the debate, and this enigma is not limited solely to South Africa. Similar metallic microspheres have been discovered in various other global regions, sometimes embedded within geological strata dating back tens of millions of years. Many contain nickel and chromium in unusual proportions, remarkably similar to those produced in contemporary metallurgy and, more disturbingly, during nuclear detonations. Volcanic eruptions and asteroid impacts are also capable of generating spheres. However, their chemical compositions do not align with what is observed in these ancient samples. Natural processes typically yield wide variations. These, however, are remarkably consistent and uniform. It's almost as if they were mass-produced, and what's even more intriguing is that certain strata are abundant in microspherules. They align with extinction occurrences where entire ecosystems vanish completely. And precisely within the identical strata, geologists uncover a dispersion of metallic spheres. Conventional explanations indicate either asteroid impacts or volcanic winters. Yet another possibility is hidden within the data, that at least some of these layers signify not natural calamities, but rather technological ones, nuclear fire fallout on a worldwide scale. At this point, prudence is essential. Extraordinary assertions demand extraordinary evidence. And a mere handful of spheres is insufficient to rewrite the timeline of human civilization. Yet the correlation is difficult to overlook because if an advanced society once inhabited Earth, these spheres represent precisely the kind of clues we would expect to persist. Neither their cities nor their art, but rather the chemical and geological scars, resulting from the forces they unleashed. Imagine for an instant a distant future. Millions of years from now, long after humankind has vanished. Our concrete will have crumbled, our steel will have rusted, and our glass will have reverted to sand. Yet a layer of radioactive isotopes will endure within the soil. Minute plastic fragments will be ensnared in the oceans and scattered throughout the sediments. There will be billions of microspherules, the enduring legacy of our nuclear age. Future scientists would not need to observe our monuments to know we once existed. They would only need to find these fingerprints, and thus we are left with an uncomfortable symmetry. Currently, our technology leaves behind indicators that future civilizations might identify. Historically, we've discovered markers appearing nearly identical, yet their ages contradict our established timeline. Should these be natural anomalies, then they represent extraordinary coincidences. If, however, they are man-made, it implies we weren't the initial inhabitants. The reality stays concealed within rock. Nevertheless, the mere existence of this discussion compels us to investigate more thoroughly at the various other enigmas Earth has presented us, given that the enigma of the spheres represents just the starting point as we delve into the narrative of life itself. Within the fossilized evidence, we encounter such immense discontinuities and profound advancements that they question our comprehension of evolutionary patterns, which nearly seem to be the product of invisible forces, either propelling life onward or eradicating it entirely. This is precisely where our exploration takes us next. Into the geological record, a chronicle from which whole sections are absent, and where the surviving pages suggest something considerably more peculiar than mere natural history. By itself, the fossilized evidence is frequently characterized as a volume, a comprehensive, elaborate account of terrestrial life. Yet upon actually opening this tome, the contents appear less like a continuous narrative and more akin to a fragmented jigsaw puzzle, with numerous components absent. There are abrupt progressions and unexplainable manifestations, along with whole segments that appear to have been removed. The more closely one examines it, the more bizarre it becomes. The most striking illustration originates from what researchers term the Cambrian explosion. Approximately 540 million years ago, for eons prior to this event, existence was rudimentary, primarily consisting of microorganisms, algae, and minute multicellular entities. Subsequently, virtually instantaneously in geological timeframes, the planet underwent a transformation. Organisms possessing shells, visual organs, and neural systems, and intricate body designs materialized suddenly. Scores of new phyla, biology's highest classifications, arose in merely a few million years. That might seem like an extended duration. Yet within Earth's vast history, it's but an instant. Evolutionary theory informs us that living organisms transform progressively through genetic mutation and natural selection. And frequently, the fossil evidence corroborates this, yet during the Cambrian period, the pace of transformation appears almost inconceivable. Rather than slow divergence, it resembles a sudden surge of intricacy, Darwin himself conceded. It constituted a significant enigma for his hypothesis. Today, researchers explain it by positing that ecological conditions abruptly permitted superior fossilization, or that specific genetic thresholds were surpassed, enabling rapid diversification. And perhaps that holds true, yet another possibility exists, one most scientists sidestep, but that persists like a shadow. What if some other factor was propelling life's advancement? The Cambrian explosion is not the sole deviation. Repeatedly, Throughout the ensuing hundreds of millions of years, we witnessed sudden emergences of entirely novel species, showing scant or no indication of forebears. Mammals materialize, then diversify swiftly after the dinosaurs disappear. Flowering plants come to dominate ecosystems, appearing almost instantaneously. Even humans emerge with unusual swiftness, possessing brains that expanded threefold in volume within merely a few million years. Each of these advancements might be attributed to randomness, but upon aligning them, the observed pattern starts to appear suspicious, and then we have the extinction events. 5 distinct times throughout Earth's history, nearly all life was eradicated by global cataclysms. Asteroids, supervolcanoes, and shifting climates are considered the conventional explanations. But what if, in at least some instances, these extinctions weren't entirely natural phenomena? What if they signified the collapse of civilizations whose end we have forgotten? Their end was marked not by craters and lava, but rather by their own missteps. If we were to disappear today, the sudden vanishing of most large animals like elephants, whales, and livestock would undoubtedly puzzle any future scientist. They might assume it was climate or a cosmic impact, only by delving deeper into the chemistry of the rocks. Would they uncover the truth? It was us. The fossil record is inherently incomplete. Soft-bodied organisms seldom leave behind traces. Entire environments can vanish without a mark. However, sometimes what is absent tells a story just as clearly as what persists. When life takes leaps that appear too significant or disappears without an obvious cause, it compels us to consider possibilities beyond the standard explanations. Perhaps the record appears fragmented because the narrative of life itself has been interrupted, reset, or guided in ways we do not yet grasp. And if that holds true, then life's history isn't solely a matter of random chance. It might be the layered chronicle of civilizations emerging, influencing their surrounding world, and then disappearing, their imprints left not in monuments, but in the peculiar rhythms of evolution. Yet fossils are not the sole record of the past. If civilizations modified Earth, their fingerprints might be found not only in bones and shells, but also within the very air itself. This brings us to another anomaly. Frozen within ice and locked in the atmosphere, there is evidence that bears an eerie resemblance to the scars of industry. Ice is one of the most powerful tools scientists utilize to study Earth's past. In Greenland and Antarctica, cores drilled deep into glaciers reveal air bubbles trapped tens of thousands, even hundreds of thousands of years ago. Each layer serves as a snapshot of the atmosphere. By analyzing these bubbles, we can reconstruct past climates, charting the rises and falls in temperature, carbon dioxide, and methane across various ages. It's akin to opening time capsules. From Earth's dynamic past, most of the patterns we observe are natural ice ages, waxing and waning with carbon cycling alongside the growth of forests and oceans. However, at various points, peculiar phenomena emerge, strata exhibiting sharp increases in carbon dioxide levels. Subsequently, it restabilizes, suggesting a rapid combustion event had occurred. Enormous quantities of organic matter, alongside abrupt surges of methane, exceeding by far the output that natural wetlands or volcanic activity could generate. Within certain ice samples, subtle indications of entirely out-of-place compounds are found. Substances that bear a striking resemblance to waste products from industrial processes. The authorized explanations remain guarded. Perhaps extensive wildfires were rampant. It's possible volcanoes emitted uncommon gases, yet the abruptness of these peaks and their uncanny resemblance to our current activities is quite disturbing. Our industrial impact is undeniable, with carbon dioxide levels increasing more rapidly than in any natural cycle. Methane levels are escalating due to farming and manufacturing, while man-made chemicals disperse into the atmosphere. Should humanity disappear tomorrow, those indicators would become permanently embedded in glacial ice and sedimentary layers for countless future millennia. Therefore, upon discovering comparable indicators in strata predating human existence, we are compelled to question their origin. Furthermore, the issue of warming episodes exists. Geologists have pinpointed eras during which Earth's temperature abruptly soared, significantly exceeding typical climatic fluctuations. Among the most renowned is the Paleocene-Eocene thermal maximum. Approximately 55 million years ago, global temperatures experienced a sharp rise. Oceanic waters became more acidic and ecological systems failed. The reasons are debated: volcanic eruptions, methane emissions, or an asteroid collision. However, the chemical indicators within the carbon bear an unsettling resemblance to what one would anticipate from extensive combustion of fossil fuels. It's the identical imprint we are currently creating. Was it simply a natural occurrence or the industrial footprint of a civilization that consumed too much, too quickly, and disappeared in its own climatic catastrophe? Skeptics claim we're overextending the data. They caution that natural processes can yield peculiar patterns and that extraordinary assertions require more than just unusual figures, which is a valid point. However, when we consider how little of our presence would endure after 10 or 20 million years, the argument becomes more compelling. Our towering structures would disappear, our orbiting devices would fall, but the atmospheric gases, the isotopes within the soil, and the abrupt chemical traces in the ice would persist. If these were to be found millions of years later, their discoverers might ponder the very same questions we are now. The atmosphere doesn't solely document weather, it chronicles civilizations. And if societies existed before us, their emergence and demise could be inscribed in invisible script preserved within ancient air bubbles. Yet air and ice constitute only a portion of the narrative. There exists another record, significantly more perilous, embedded not in gaseous forms, but within the very atoms comprising the Earth. This record implies that long ago someone might have unleashed the power of the atomic nucleus itself. In 1972, within a uranium mine in Oklo, Gabon, scientists made a significant discovery, a finding that profoundly impacted the foundations of both physics and geology. At first inspection, the ore seemed unremarkable. Uranium-rich rock, much like that extracted from numerous other locations. Yet when researchers examined its isotopic composition, they uncovered something deemed impossible. The uranium had already undergone a nuclear reaction. The isotopic proportions were identical to what one would anticipate from fuel rods within a nuclear reactor. To put it another way, at some point in the distant past, chain reactions had spontaneously occurred within the Earth itself. This proved to be an astonishing revelation given that natural nuclear reactors were previously considered impossible. And yet, here was irrefutable evidence that self-sustaining nuclear fission had indeed occurred. Dating back nearly 2 billion years, geologists quickly sought to provide an explanation. The conditions at Oklo were uniquely optimal. Groundwater effectively slowed down neutrons, precisely enough to sustain the chain reaction, indicating that nature, against all expectations, had constructed its own nuclear facility. Yet this discovery also demonstrated something further. Nuclear traces exhibit extraordinary durability, remaining detectable even after billions of years. The isotopic imprints of those reactions remain distinct and discernible within the stone. This realization prompted a disquieting question. What if our own civilization were to disappear tomorrow? Evidence of nuclear activity would persist well beyond the erosion of our urban centers. The residual effects from armaments trials, along with the depleted fuel interred beneath the surface. The planet-wide distribution of radioactive isotopes, every bit of it would remain discoverable. Even millions of years hence, nuclear processes, once set in motion, cannot be concealed from the passage of time, leading us to a perplexing question. Why, then, do we uncover nuclear-like indicators within geological formations that predate human existence by tens of millions of years? In Kazakhstan, uranium deposits exhibit isotope ratios strikingly akin to those generated during controlled experiments. These do not correspond to the output of natural reactors, such as Oklo. Rather, they align with the remnants of a weapons detonation. Throughout 6 continents, geologists have documented unusual strata containing seemingly artificial isotopes, plutonium, cesium, and strontium. These particular elements are not found naturally in such high concentrations at their discovery sites. Some of these isotopes are typically generated by contemporary reactors solely under stringent regulatory controls, yet they are preserved within primeval rock. A single specimen extracted from Greenland's deep ice cores revealed radioactive isotopes, the creation of which would have necessitated technology surpassing anything developed by humans prior to the mid-20th century. That ice dated back hundreds of millennia. Should these isotopes not be naturally occurring, then an entity or force must have deposited them long before our time. The ramifications extend broadly. Pacific Ocean sediment reveals plutonium traces that correspond nearly precisely with one of Earth's most significant mass extinction occurrences. Had natural catastrophes been the cause, we would anticipate volcanic emissions, asteroid fragments, or methane surges. Conversely, we observe isotopes exclusively originating from nuclear detonations. Was this mere chance, or were we witnessing the chemical footprint of a conflict that eradicated whole ecosystems? The evidence becomes even more disquieting due to its apparent systematic nature. Within certain geological structures, isotopes manifest in distinct, regular bursts. Periods of intense activity followed by dormancy, then another surge millennia afterward. This is precisely the pattern one would anticipate from a civilization conducting weapons trials, rather than a disordered geological phenomenon. Intriguingly, ancient legends appear to corroborate this. In India's Mahabharata, combatants deploy armaments that cause the heavens to radiate like an additional sun. Entire urban centers disappear in explosions that render those who survive bald and unwell, their sustenance contaminated. Conventional historians interpret these accounts as allegory, poetic license, or hyperbole. However, when juxtaposed against Earth's ancient history, these accounts bear an unsettling familiarity. It's important to note that science hasn't established any of this as conclusive proof. Conventional explanations always remain possible. Prudence is certainly required. Nevertheless, each unusual isotopic signature, every radiological trace within the geological strata, compels us to ponder, are we truly the initial inhabitants, or are we treading upon the remnants of predecessors, who harnessed atomic power ages prior to our time, only to perish in the cataclysm they initiated? For if atomic echoes persist within the geological formations, they represent more than mere evidence of devastation. They serve as admonitions, and should we ourselves disregard these signals, then we too may be reduced to just another isotopic stratum interred within the rock, one more lost society within Earth's recurrent pattern. If you wish to know what will characterize our species' impact on Earth, do not observe the most towering high-rise or the most expansive metropolis, nor even consider stone-hewn memorials. Focus instead on plastic, from the initial cellophane packaging to the vast quantities of minute plastic particles now circulating in every ocean stream. Our planet is permeated by it. Microplastic fragments descend with precipitation. They deposit in snowfall on isolated mountain peaks and circulate within abyssal ocean ravines. Researchers have even discovered them solidified in Arctic ice and integrated into the tissues of fauna. Far into the future, when our machinery corrodes and our glass disintegrates, polymers will endure. They will be compacted into geological layers and lithified into novel stone formations. Earth scientists refer to this forthcoming stratum as the plastiglomerate, and it may represent the most unambiguous geological indicator of our epoch. Now picture discovering such a material in rocks, predating human existence by a vast span. Precisely this is what some researchers claim to have reportedly found while extracting core samples from the Pacific and Atlantic Ocean floors. Scientists revealed polymeric remnants in deposits from many tens of millions of years ago. Initially, the hypothesis pointed to mere contamination. Contemporary drilling apparatus, containment vessels, or even laboratory instruments could inadvertently deposit plastic materials in inappropriate locations. However, protocols for detecting impurities became more rigorous, and in certain cases, the discrepancies remained. Some pieces were interred at excessive depths within strata that had been sealed off well before the emergence of humankind. When viewed under microscopes, they bore no resemblance to natural polymers like amber or bitumen. Rather, they exhibited recurring molecular sequences and structured, man-made appearances resembling polyethylene or nylon. Adding to the strangeness, some of these fragments demonstrated greater resistance to degradation from heat and UV light than contemporary plastics. Assuming they weren't mere contaminants, they could signify fabricated substances intended to persist for eons. In essence, these were materials purposely created for longevity. Furthermore, plastics are not the sole unusual findings. Minute metallic spheres and pieces have surfaced within global sediments. Their chemical composition occasionally reveals alloys, mixtures of metals such as nickel, chromium, and iron which seldom naturally coexist. On occasion, their makeup reflects the formulations found in contemporary stainless steel, while volcanic activity or meteorite impacts confuse metals in unusual manners. However, the consistent nature of these samples implies deliberate creation over chance occurrence. It's important to note that the majority of geologists approach these findings with skepticism. The most straightforward explanation is contamination, and exceptional assertions necessitate exceptional proof. Nevertheless, recurring patterns hold significance. An isolated fragment might be disregarded, yet their widespread distribution across oceans, continents, and geological strata starts to hint at a grander phenomenon, indicating activity that briefly emerged in ancient times, then disappeared. Consider what our civilization's imprint will resemble millions of years hence. Picture a geologist far in the future, boring into the Earth's crust. They will not discover complete skyscrapers or corroding automobiles. Instead, they'll uncover a narrow stratum containing unusual substances, such as aluminum, a metal almost non-existent naturally until human smelting processes. Man-made polymers unfamiliar to biological systems, alloys configured in proportions seldom found in nature, chemical superfertilizers, pesticides, and industrial waste products. For them, we will constitute a layer of anomalies, clearly identifiable yet fragmented. Therefore, when examining ancient sediments and observing polymer-like fragments and engineered-looking alloys, the mirroring effect becomes difficult to disregard. These are precisely the types of indicators our own civilization is currently leaving behind. If they are indeed contamination, they represent perplexing coincidences. However, if they are authentic, they are faint echoes of predecessors who industrialized and subsequently left nothing but their refuse, exactly as we are doing today. Furthermore, even more peculiar assertions exist within the periphery of archaeology, namely out-of-place artifacts items that seem to contradict the age of their surrounding rock, such as a metallic sphere discovered within. A piece of coal dating back 600 million years, alongside an aluminum fragment that looks like mechanical components. Extracted from a Romanian quarry, the majority of these items are typically dismissed as fabrications, or simply misunderstandings, which many likely are. However, the continued existence of these narratives, coupled with authentic irregularities found in geological layers, sustains the inquiry. What if some of them are authentic? What if these are remnants of industries obliterated by the passage of time? What renders this concept unsettling is the extent to which industrial societies would vanish following their downfall. In just a few millennia, forests would reclaim urban areas. In a few million years, glaciers and oceans would completely obliterate the terrain, yet the materials, the plastics, the alloys, the resilient synthetic substances would persist, interred and awaiting discovery. And this perhaps constitutes the most significant caution we are generating. The precise proof that would incriminate us as a civilization even if everything else disappears. Polymers destined to endure longer than our languages, metallic compounds that will outlive our governance systems, chemical signatures that will persist beyond our species. One day, another intelligent entity might examine our remnants and ponder, much as we do now, if they are observing the heritage of a civilization that emerged, flourished brilliantly, and subsequently vanished. Should Earth conceal such substances from bygone eras, then perhaps their presence is not coincidental whatsoever. Conceivably, they represent the imprints of prior civilizations, ones that delved into chemistry and engineering, dispersed their innovations across the globe, and were subsequently forgotten by history. And if they attained such a level, why presume they confine themselves to Earth's surface? Because if industry and advanced technology once thrived here, the subsequent rational progression would be outwards, into orbit, to the lunar surface, and throughout the solar system itself. It is to this realm that we now direct our attention, seeking evidence that might reside not within rocks or oceans, but beyond our planet entirely. Typically, when we envision civilizations, we imagine them anchored to the Earth, tied to waterways, flatlands, and shorelines. Yet, in merely a few generations, humankind has advanced from rudimentary stone implements to interstellar travel. We have deployed satellites into orbit, left marks on the moon, and sent probes past the solar system's boundaries. Should our existence conclude tomorrow, some of our most lasting indicators would not be found on Earth whatsoever. They would be suspended above it or patiently awaiting discovery on celestial bodies devoid of atmosphere. This brings forth a disquieting query. If we have already disseminated artifacts beyond our home world in merely 100 years of industrial activity, what if another civilization possessed millions of years to accomplish the identical feat? Should they have aspired to the heavens, what indications might they have bequeathed? The initial intimations of this potentiality. During the initial decades of the space era, engineers observed an unusual phenomenon. Its origin was not from telescopes, but from radio aerials. Radio signals transmitted from Earth occasionally returned as long-delayed echoes, reappearing several seconds later, which was significantly longer than typical reflections. While certain scientists attributed this to atmospheric interference or lunar reflections, others pondered the possibility of an artificial object in space intercepting and retransmitting our signals. Resembling a celestial mirror, this occurrence remained unexplained and eventually receded from public awareness. Nevertheless, it sparked a notion. Perhaps Earth's orbital space is not as vacant as it appears. This concept captivated the public's imagination with the narrative of the Black Knight satellite. During the 1960s, radar personnel identified peculiar objects in polar orbit, even though neither the United States nor the Soviet Union possessed satellites in such an alignment then. Subsequently, in the 1990s, astronauts on various missions captured images of a dark, angular entity hovering above Earth. NASA maintained it was merely space junk, probably a detached thermal blanket. However, for many, its appearance seemed too peculiar, too intentional. Conspiracy theories proliferated, asserting the Black Knight was an ancient satellite, possibly millennia old, abandoned by a lost civilization. While the reality is likely unremarkable, its symbolic significance persists. Should humankind cease to exist tomorrow, our satellites would persist in orbiting Earth for hundreds of years. Certain ones, in stable trajectories, might endure for tens of millennia prior to their disintegration. For any future intelligent beings, these would seem every bit as enigmatic as the Black Knight appears to us. While orbit serves as the primary location for investigation, the Moon ranks as the secondary. In contrast to Earth, the Moon lacks an atmosphere, weather patterns, and erosion. Objects found there might endure for millions or even billions of years. Already, Apollo mission astronauts deposited flags, lunar rovers, and scientific apparatus. These serve as quiet indicators of our existence. If a different civilization had visited long before our time, their remnants could still be present, concealed just beneath the lunar dust. Certain irregularities spark conjecture. Luminous flashes observed within craters, and vitreous spheres dispersed across the surface in atypical groupings. Officially, these phenomena are attributed to volcanic glass or impact-generated melts. Yet what if some represent vestiges of industrial operations, mining waste, or fragments from ancient endeavors? This is a stimulating idea, particularly considering the enduring nature of the lunar surface. If our imprints can persist for millions of years, why couldn't others have achieved likewise? Furthermore, billions of years ago, Mars was a planet characterized by lakes, rivers, and potentially oceans. Had life been afforded the opportunity to develop there, intelligence could have subsequently emerged. In the 1970s, when Viking probes transmitted the initial close-up photographs, a particular image captivated the globe. This was a mesa within the Cydonia region, which when viewed in shadow resembled an enormous face. Subsequent high-resolution imagery confirmed it was merely a natural geological feature, yet the fervor it generated highlighted a significant insight. We are predisposed to perceive significance in irregularities, and despite this, Mars continues to harbor enigmas. Meteorites ejected from its surface exhibit peculiar microscopic structures. Some mineral formations, once thought to look like fossilized bacteria, indicate chemical processes. These processes, though explainable, don't entirely align with natural expectations. Should Mars have once hosted an intelligent civilization, its remnants might lie buried, beneath kilometers of dust and sand unseen by orbiting cameras. Only extensive exploration, drilling, and excavation could either confirm or refute this. Considering Mars's ancient capacity for life, the inquiry remains highly intriguing. Past Mars, we encounter the asteroids. For us, they represent rich reserves of metals like iron, nickel, platinum, and cobalt. Companies are already making plans to extract these resources. Should we succeed, the marks left by mining will persist for millions of years. Certain asteroids already display unusually geometric ridges or furrows that don't entirely correspond to natural patterns of rotation and impact. Most are likely geological coincidences. However, we are once more compelled to ponder the reflection. If we would leave such traces, why wouldn't others? Some researchers even propose looking for technosignatures closer to our own planet rather than scanning distant stars for extraterrestrial radio signals. What if we thoroughly searched our solar system for remnants, artifacts, or mining evidence left by prior civilizations? In recent times, this concept has gained considerable acceptance. An object such as Oumuamua traversing our system ignited discussion regarding its natural origin, or if it was a piece of technology. If remnants of civilizations are capable of drifting between stars, then proof could be nearer than we imagine. This brings forth a serious consideration. Should signs be present in orbit, on the Moon, on Mars, or within the asteroid belt, they could endure longer than any other indication on Earth. Our world continually obliterates itself through erosion, tectonics, and oceans. However, space acts as a preserver for artifacts located there. This might be the most authentic legacy any civilization could leave behind. Therefore, when we gaze into the sky, we might not solely be searching outward for other life among the stars. We could be peering backward into the profound history of our own planet. And if a discovery is made, the question that will resonate more loudly than any other isn't just what they bequeathed, but why they disappeared. This brings us to the concluding, most disquieting segment of this expedition, the recurring cycle of civilizations emerging, flourishing, and then descending into silence. When we narrate our own history, we typically conceive of it as a linear progression, a journey from rudimentary dwellings to metropolises, from the first sparks of fire to nuclear energy, from ancient tales to scientific knowledge. Yet history seldom progresses in a linear fashion. It cycles, it crumbles, it obliterates itself. And when we gain enough perspective, looking beyond the ascent and decline of empires, past the fleeting existence of cultures and kingdoms, what we discern is a rhythm. Civilizations don't just emerge, they ascend and then repeatedly collapse. The Romans were convinced they had constructed something everlasting. Their aqueducts spanned Europe and their armies extended from the Atlantic to the Middle East. But drought, illness, corruption, and the gradual, crushing burden of overextension ultimately brought the empire to its downfall. The Mayans erected immense cities concealed within the jungles of Central America. These were aligned with the stars, radiant with artistic and scientific achievements, until their downfall arrived. Environmental pressures, warfare, shifting trade routes, and perhaps even internal rebellion. The magnificent urban centers were engulfed by the encroaching forest. Their narratives were silenced. Angkor in Cambodia, Easter Island in the Pacific, Cahokia in North America. Each instance conveys the same narrative, though with different details. Periods of brilliance succeeded by quietude. Now, project that identical pattern onto Earth's profound geological history. The fossil record functions as a chronicle, not solely of life, but also of collapses, surges of creativity, abrupt extinctions, and tenuous recoveries. Take, for example, the Cambrian explosion, when complex life forms emerged almost instantaneously. The massive extinction event at the close of the Permian period, during which nearly all species disappeared. This was the cataclysm that eradicated the dinosaurs, thereby paving the way for mammals. Each of these instances bears an uncanny resemblance to the emergence and decline of civilizations. It's inscribed within biology, a sudden ascent, a violent collapse, followed by a reset. If intelligence has emerged on Earth before, this is precisely how its traces would appear. Not as cities preserved in stone, which vanished too quickly, but as indelible scars etched into the planet itself. Elevated carbon levels preserved within sediments, isotopic fingerprints that do not align with natural processes, synthetic particles embedded in ancient rock formations. These are vestiges of technologies that outlast their builders, but not their original purpose. Every such cycle would leave behind a surge of activity, each collapse a period of quietude, and then the planet would attempt anew. This recurring pattern is known in modern astrobiology as the Great Filter. This concept posits that life might be widespread throughout the cosmos, yet intelligent species rarely survive their own early developmental stages. Civilizations may bloom like flowers, but most wither before they can propagate their influence among the stars. The quietude we perceive when directing our telescopes outward into space might not signify our solitude. Instead, it could indicate that the majority of other intelligent life forms have already ceased to exist. What is truly alarming is the precise alignment of the Great Filter with our current trajectory. We have fractured the atom and contaminated the soil with isotopes that will remain detectable millions of years from now. We have elevated atmospheric CO2 to concentrations not observed since the prehistoric hothouse Earth. We have blanketed the oceans and continents with plastics, leaving behind a layer of synthetic dust that will never fully decompose. In merely a few centuries, we have generated the precise kind of anomaly that scientists currently puzzle over in ancient rock formations. We are already the spectral remains of a civilization that future geologists will undoubtedly investigate. Our exploration commenced with something minuscule, metallic spheres encased within stone. These objects were so peculiar they compelled us to question whether we truly comprehend our own past. Our investigation then led us through fossils, atmospheric data, isotopes, polymers, lunar observations, and stellar phenomena. Individually, the clues were subtle and fragmented, yet collectively, they hinted at a concept almost too vast to grasp. The notion that humanity might not be the inaugural civilization on Earth, and if that holds true, then we are likewise not the first to collapse. The fossil record reveals a pattern of extinctions and subsequent revivals, a cadence that seems less coincidental. Instead, it resembles a memory. The elemental signatures, the atmospheric scars, the puzzling irregularities. Perhaps ancient warnings are etched in stone, indicating that others existed. They attained this stage and subsequently disappeared. Yet these can be viewed differently. They might not solely serve as warnings. Instead, they could demonstrate the inherent resilience of intelligence. That awareness reemerges repeatedly, much like a fire the planet is unable to put out. In that case, we are not positioned at a precipice, but rather at a divergence in our journey. One path leads to downfall, the other to persistence. The vast quietness of the universe weighs heavily upon us. No vast interstellar empires are visible to us, nor do we detect any transmissions from celestial bodies. It's possible that the Great Filter is a genuine phenomenon and that the majority of advanced societies self-destruct prior to expanding. However, quietude does not equate to evidence of failure. Instead, it serves as an invitation. Should no entity have endured sufficiently to establish a distinct signal, then perhaps our purpose is to become the pioneers. For the most profound enigma is not if predecessors existed. The paramount question is whether humanity will persist into the future. Should you enjoy this content, please remember to give it a thumbs up and subscribe. Your support significantly impacts us and aids the channel's expansion.